Today we will discuss astronomy, data and image analysis. So we will discuss how astronomical data is important in our modern society for analytical purpose. So it is an important issue in image analysis and data analysis because in any image or data, most of the data are have no information, and in very limited space informations are there. Thus we can say that data are sparse in nature in most of the cases. So there should be some methodology so that we can find the important information and leave or discard the irrelevant or those information which have no value at all. So when we consider the ever increasing amount of astronomical data available to us, we can well say that the needs of modern astronomy are growing by the day. Ever better observing facilities are in operation. The fusion of information leading to the coordination of observation is the central importance. So we have to study the different methods that will help to analyze those huge amount of astronomical data. The early years of the third millennium are interesting times for astronomy. As a result of the tremendous advance in our computing and information processing, environment and infrastructure. The advances in signal and image processing methods we are going to study here. Unlike in Earth observation and meteorology, astronomers do not want to interpret data and having done so, delete it. Variable objects, supernova, comets, etc., bear witness to the need for astronomical data to be available indefinitely. The unavoidable problem is the sheer overwhelming quantity of data which is now collected. The only basis for selective choice for what the information extraction and knowledge discover process. We have to go understand our scientific knowledge discovery mechanism better in order to make the correct selection of data to keep long term, including the appropriate resolution and refinement levels. We have got to understand our scientific knowledge discovery mechanism better in order to make the correct selection of data to keep long term, including the appropriate resolution and refinement levels. The vast quantities of visual data collected now and in the future present us with new problems and opportunities. Critical needs in our software systems include compression and progressive transmission support for different detail and user navigation in data spaces and thinware, transmission and visualization. The technological infrastructure is one side of the picture. Another side of this same picture, however, is that our human ability to interpret vast quantities of data is limited. A study by Dr. William CERN has quantified the maximum possible volume of data which can be conceivably be interpreted at CERN. This point to another more fundamental justification for addressing the critical technical needs indicated above. This is that selective and prioritized transmission, which we will term intelligent streaming, is increasingly becoming a key factor in human understanding of the real world as medical through our computing and networking base. We need to receive condensed summarized data fast and we can aid it in our understanding of the data by having more detail added progressively. A hyperlinked and networked world makes this need summarization more and more acute. We need to take resolution scale into account in our information and knowledge spaces. This is a key aspect of intelligence streaming system. A further area of importance for scientific data interpretation is that of storage and display. Long-term storage of astronomical data we have already noted is part and parcel of our society's memory. With the rapid observation of storage devices, considerable efforts must be undertaken to combat social amnesia. The positive implication is the ever increasing complementary of professional observation astronomy with education and public outreach.